So I was thinking about this angle sum formula. So sine of alpha plus beta equals sine alpha cosine beta plus cosine alpha sine beta. And I was thinking about deriving it. I couldn't remember having done it before, but it's not too difficult. Okay, so let's assume that alpha and beta are both acute. I think if you can show it for them both being acute, you can probably show it for all the angles. So if they're acute, I could draw the triangle here with 90 degrees and the height h. This angle is alpha, this angle is beta. Let's call these sides x, y, m, and n are the two sides. And then we can use the sine rule. The sine rule says, on the big triangle, to get sine alpha plus beta. So the long side, m plus n, dividing sine alpha plus beta is equal to, you can choose any of the other sides now, and I just chose this angle. So I called beta bar 90 minus beta, and then divided by y. Okay, so rearranging gives this, and we note here that sine of beta hat is actually cosine of beta, and yeah, that's where the name comes from as well, just complements it. 90 minus beta, sine of 90 minus beta is cosine beta. So, and then n over y is sine alpha, and m over y, well, that's not really anything at the moment. So I wrote sine alpha here, and then, so when you expand this, the n over y is sine alpha times cosine beta, so that's what I put here. And for this other term, I rewrote cosine beta as h over x. So h over x times m over y. So I put the x under the m instead, and I put the y under the h, and because m over x is now sine beta, and h over y is cosine alpha. Okay, so this is sine beta cosine alpha plus sine alpha cosine beta, and this is just yeah, I mean, this is the same as what we were trying to prove, it's just written the other way around. Maybe you can try to play around with how to make this true for all angles at alpha and beta, not just the acute ones.